Welcome back to the channel, guys. Today we'll be covering supervised learning, and what we'll do is we'll get our hands dirty. So far, we have been going through the theoretical knowledge, but uh, if you want to really learn machine learning, right, you should have hands-on experience as well. So uh, we'll go through the code. So if you look at this first, so I'm using Jupyter. So before I start the code, right, I'm using Jupyter notebook to do the analysis. I expect that you guys are aware how Jupyter notebooks work. If not, you can install Anaconda into your machines. And if you need a video around it, you can let me know, and I can create a separate video. So we'll give it a start. So this is a Jupyter notebook, and this is where I'm importing all the required libraries. NumPy NumPy as NP is the array library which can give you two-dimensional, three-dimensional array. Matplotlib is something that is used to plot graphs. Linear regression. So sklearn is an important library that we'll be learning. We'll be working and learning around during these sessions. So we'll be importing the linear regression model from linear model. Then we'll be importing train test split. We'll go through the code away and I'll let you know why did we do that. We'll be importing mean squared error and R2 square from the matrix. We'll go through the details of mean squared error and R2 score as well in while we go along the code, right? So first is we have created two arrays. One array has the so the problem that we are trying to solve is we are trying to predict the house prices. I think this is the most common example you will see across the internet. The reason I've taken it is that it is simple, right? You can correlate and it will be easy for you to give it a start, and then we can go on to solve complex problems, right? So this is just area and square feet. The equation is similar, right? What we are trying to achieve y using x, where there will be some coefficient a and there will be some intercept value v b, or vice versa. You can say based upon our last previous example, right? This is the equation we are trying to solve as part of the linear equation. Y is that we are trying to know, and x is something that we are aware, right? So x is the price, is the square feet area of the houses, and corresponding to that we have the price of the houses. So this basically cell means that 500 square feet house will have the price of 150,000 k, right? So this is what it denotes. Okay, so we have created a sample data now. Okay, if you remember, we imported this, right? Why we did it? Because we wanted to split the data into our uh, training and testing, for training and testing. So this is how we split x as well as y for training and testing, and this is train test, and we do the test size as zero point 0.3, which means 30%. I put a note across here as well as for documentation purpose. And we do a random test 42, so that the split is reproducible, else it will start splitting it on any basis, right? So we always want to split it on the particular for we don't want it to be random, right? Basically, yeah. Now coming is we create. Okay, I am not running the code. Give me a second. Let me start running as well. This is done. Okay, it will give a syntax error, right? If I do it now, it works. Okay, now I create a model, linear regression, and I fit the data, right? X train, we got it from here, and Y train. We have fitted the data in the model. Now we predict on the test data, right? So Y prep model. So y x test is something is that will be the test data input. Y is something that we'll be getting at the as the output, right? Now we will evaluate the model. uh, y test is that we are getting from here, which we know, and y predicts is something that we have calculated, and so these two, right, mean squared error and R2 score. So basically, mean squared error we use to predict how well the model is working, right? It basically calculates the average of the squared difference between the predicted values and the actual values. So we want it MSCB to be small, right? So that smaller the MSCB, the lesser is the difference between the actual value and the predicted value. Coming to R2 score, uh, uh, also called as the coefficient of determinant to evaluate how well the regression model has fitted your data, right? So better model, the better the model fit, the higher will be the R2 score. Okay, now let's quickly calculate these two value. Okay, so look at this, right? R2 score, mean squared value error is 563 and R2 score is 0.98. Okay, now coming, we'll plot this data and we get this. So we, if you look at here, right, we are getting the intercept and we are getting the slope as well. Okay, so this is all we do. I've just plotted the linear regression, right, for training data. This is what we have. Yeah, uh, that covers on a high level of what. So these two are important terms, right? You should be aware of this. This is how you will be testing, evaluating your model. So the smaller the MSC, the better the model, and the uh, higher the R2, the better the model is performing, right? Yeah, thanks. We'll go through unsupervised learning in the coming lectures. Yeah, thanks everyone.